So I we see AI doing these pretty incredible things these days, don't we?
Oh, absolutely.
Generating really sophisticated text, creating amazing images, helping with medical diagnoses, even beating the best humans
Yep.
at really complex games.
Yeah.
It feels just incredibly capable, like almost smart. And that reaction, it kind of leads us straight to this really fundamental question, doesn't it?
Yeah.
Does all this mean AI is actually reasoning the same way, we do?
That question really is right at the heart of the whole AI discussion now. It's so easy, almost natural, to look at what these systems produce and kind of map our own thinking onto it.
Yeah.
But when you really dig into how they're doing it, well, the actual mechanics are just fundamentally different from human reasoning.
Okay, so let's unpack that. We've got some great material here to guide us. And our mission for this deep dive is really to, well, get to grips with that core difference.
Exactly.
We want to try and clearly distinguish AI's data processing, what it actually does, from human cognitive reasoning. Explore how current AI manages these amazing results without what we'd call true reasoning.
Yeah, pinpoint its limitations too.
Right, pinpoint the key limitations compared to us, and then maybe look ahead at the big challenges researchers face trying to get AI closer to mimicking, more advanced thinking.
The real aim here, I think, is to build a solid, kind of realistic understanding for you of what current AI is and what it isn't.
Right.
It's about giving you a clear foundation, cutting through maybe some of the shapes so you can think about its capabilities, its limits, and where it might actually be going.
Yeah, I know diving into AI concepts can sometimes feel a bit complex, but we'll definitely take it step by step. We'll pull out the key insights from the material to make this distinction really clear for you.
Absolutely. So maybe let's start by trying to define what we even mean by human reasoning in this context, because the material we've got lays out some really key aspects that make it different.
Good idea. Because, when we just say reasoning, it's not one simple thing, is it?
Not at all.
The material talks about human reasoning as this incredibly advanced skill with like multiple layers all connected. It's not just about processing information. It's built on deep understanding. We get meaning, context, nuance, the relationships between ideas in this really rich sort of semantic way.
And what's really fascinating there is how our understanding goes so much further than just spotting patterns, right?
Yeah.
Humans have this almost innate ability to see causal relationships figuring out cause and effect. We don't just notice A and B happen together often.
Right.
We start to infer that maybe A causes B or the other way around. And tied into that is, inferring logical conclusions, filling in gaps even when we don't have all the pieces.
And that feels inextricably linked to that amazing, almost invisible thing the material brings up, common sense.
Ah, yes, the big one.
Yeah. We have this huge, kind of messy internal model of just how the world works. Generally, it's that unspoken knowledge letting us handle new situations pretty easily without needing specific training for every single possibility.
Yeah.
We just know, if you let go of something, it falls. And AI has to learn that purely from, like, millions of examples showing that correlation.
Precisely. And another critical piece here is abstraction and generalization. Humans can create abstract concepts to think about freedom or justice. And we can take principles we learned in one very specific situation and apply them broadly to totally new contexts. That flexibility, that's really a hallmark of how we think.
Plus, the material points out something really fundamental: consciousness and reflection. We're actually aware of our own thinking.
Yeah, that metacognition.
We can think about our thinking, critique our own reasoning, spot errors, change strategies. There's a subjective experience to it all.
So, okay, that's the complex, multi-layered picture of human reasoning. Now, let's contrast that sharply with how current AI systems, especially the powerful machine learning and deep learning models we see everywhere, actually operate, under the hood.
Right, and this is where it gets really fascinating, because the outputs can look so convincingly human, sometimes almost like magic. But the material is super clear. The intelligence we're seeing is mainly the result of large-scale pattern recognition. These systems are just exceptionally good at finding incredibly complex statistical connections and patterns hidden within absolutely massive data sets.
Think about using an AI to spot a cat in a photo. Or maybe that medical image example.
Okay.
It's not that the AI understands what a cat is, its catness or nose anatomy. It's because it's learned to associate certain patterns of pixels or features with the label cat or with a particular condition,
Right.
based purely on analyzing millions, maybe billions of previous images where that pattern consistently showed up in the data it was trained on.
So it's basically finding the most likely connections in these huge oceans of data. And this is all driven by algorithmic optimization, right?
Exactly. These are sophisticated algorithms designed purely to get better and better at one specific task, maybe classifying things, predicting things, generating things, by mathematically reducing errors and strengthening those statistical links. Their impressive decisions or outputs, they're the result of these complex probability models running on patterns they've learned.
And this is so crucial when we talk about large language models, the LLMs. The material really emphasizes these models do not understand language like you or I do.
Not in the human sense, no.
They generate text by calculating, essentially predicting, the statistically most probable next word in a sequence.
Yeah.
Drawing on all the patterns, the grammar, the style, the factual correlations it absorbed from, well, trillions of examples in its training data.
So they can produce incredibly fluent, grammatically perfect, sometimes seemingly insightful text.
Yeah.
But that ability comes from statistical prediction, not from actually grasping meaning or having any kind of intent behind it.
It's like this phenomenal simulator of understanding.
It's a good way to put it.
Built purely on pattern matching at an unimaginable scale. It can sound like it gets it because it's learned the statistics of our language so incredibly well,
Right.
but it doesn't actually possess that understanding.
And fundamentally, as the material really underlines, current AI absolutely lacks consciousness, self-awareness, or any kind of subjective experience. There's no lights on inside, no internal world, no feelings, no qualitative awareness of its own processing or existence like a person has.
You know, the material even touches on older types of AI, like rule-based symbolic AI.
Right. UFAI, good old-fashioned AI.
Yeah, which worked on explicit logic rules like, if this happens, then do that. And while that was a form of programmed logic, its reasoning was strictly limited to whatever rules the programmers put in.
It couldn't really generate new logical ideas or handle things way outside its programming.
Exactly. Modern AI learns patterns from data instead of being explicitly told the rules, but it's still fundamentally operating on those learned patterns, not, creating new logical frameworks from scratch like a human mind might.
So, okay, given these huge differences, how can we really get our heads around this distinction? Maybe an analogy could help here.
Oh, yeah. The calculator analogy from the material is perfect for this, I think.
Right.
Think about a really advanced scientific calculator. It can do incredibly complex math, way faster and more accurately than pretty much any human, right?
Absolutely.
But the calculator doesn't understand math. It doesn't grasp concepts like number or addition in any meaningful way. It's just running algorithms on symbols, according to its programming.
Exactly that. Current AI, you could say, is like an incredibly powerful, complex tool running algorithms and spotting patterns in data. It's this unprecedented engine for processing information, for simulation. But it fundamentally lacks that deep semantic understanding, the intuition, the common sense, the conscious awareness, all the stuff that really defines human cognition and reasoning.
So bringing it back to that core insight from the material, while current AI is no doubt a transformative tool capable of processing data on a scale we've never seen before, it fundamentally lacks true human cognitive faculties.
Yeah, that's the crux of it.
It doesn't have genuine understanding or causal reasoning or common sense or consciousness. Its impressive outputs come directly from recognizing and exploiting statistical patterns learned from vast data sets, not from a process of logical deduction or abstract thinking like ours.
And recognizing that difference is just so vital, isn't it? For setting realistic expectations about AI, appreciating what it can do brilliantly, but also understanding its inherent limits.
Yeah.
It helps us see where AI is this amazing tool, this powerful lever, and where human thinking remains, well, unique and irreplaceable, at least for now.
Now, the material doesn't just stop there with the current state. It does look ahead, outlining some of the really challenging frontiers researchers are exploring. They're aiming to build systems that might emulate aspects of that more advanced human reasoning?
Indeed. The scientific community is definitely pushing hard to try and bridge some of these gaps, not necessarily to perfectly replicate a human mind, but to build more capable, maybe more flexible systems.
Right.
And one huge area highlighted is causal AI. The goal there is to move beyond just correlation like A happens with B, and actually equip AI with the capacity to understand cause and effect, to figure out if A causes B.
Wow, okay. That feels like a massive leap in complexity right there.
It absolutely is. And then there's what the material calls one of the, maybe the biggest hurdles, artificial common sense.
Yeah. How do you even begin to teach a machine all those thousands upon thousands of obvious unspoken truths about the physical world, the social world, the stuff humans just kind of absorb effortlessly from day one?
Integrating that vast, complex, often quite messy real-world knowledge into a system that can actually use it. Incredibly difficult.
I bet.
Another interesting direction mentioned is neurosymbolic AI. This research tries to combine the strengths of both worlds, you could say.
Oh, so?
Well, combine the pattern recognition power of today's neural networks with the more explicit logical reasoning abilities of those older symbolic AI approaches. The idea is to get a system that can learn from data and apply structured rules and logic to what it knows.
Okay. Kind of the best of both worlds.
That's the hope. They're also looking at ways to make AI learn more efficiently, more like how humans often learn from just a few examples. The material mentions few-shot learning, the goal being for an AI to grasp complex ideas or tasks from just a handful of data points instead of needing these mountains and mountains of information we currently feed them.
That would be a game changer.
Definitely. And finally, improving transfer learning and generalization. Basically, developing AI systems that can take knowledge or skills they learned doing one thing and effectively apply them to totally new and different problems. That would show a much higher level of cognitive flexibility than most AI has today.
These are clearly really challenging research areas focused on simulating specific bits of human reasoning.
That's right.
But the material makes it pretty clear these are complex steps towards simulating those capabilities, not necessarily getting to the full depth, or certainly not the consciousness, of human thought.
So let's just circle back one last time to that core distinction we've been exploring. Current AI. It excels at large-scale pattern recognition, statistical processing. It's a powerful, data-driven tool built on complex algorithms and correlations learned from massive data sets.
But it fundamentally does not possess that deep semantic understanding or causal inference or common sense or consciousness that are really the hallmarks of human reasoning. Its impressive outputs, however smart they seem, are born from those statistical patterns, not from a human-like process of logical deduction, abstract thought, or conscious awareness.
And those challenging frontiers of research we just touched on, they really just highlight how incredibly complex and difficult these human cognitive abilities are to replicate, even when the goal is just simulating specific aspects.
Right, and really understanding this, it leaves us and you with a pretty thought-provoking question to mull over, doesn't it?
If AI fundamentally operates by processing patterns without having true understanding, what are the implications? Especially as we increasingly rely on it for, say, complex decision-making or for creative work, or even in areas where we're trying to define what's true or real. How does this core distinction between statistical pattern matching and genuine human understanding, how does that shape your perspective on the future relationship between us humans and these incredibly capable machines?